Thank you. Yes, my name is John Lockwood. I'm a software engineer at Workiva, where we build products for large distributed organizations. We build products that our users use to collaborate in large distributed organizations. We build it using distributed systems, and we're a pretty distributed company. We have offices around the country and around the world. So first I want to talk about a little bit of the history of front-end web development. JavaScript first came out in 1995, and it was over a decade later before we had cross-browser compatibility libraries such as jQuery. These helped us manipulate web pages more easily and deal with need my notes after all. So JavaScript was slow in the early years. It wasn't used for a lot of things because it was so slow. But as more and more, as computers got faster and JavaScript interpreters got faster, people started to use those resources instead of their old JavaScript running faster. They started to write more code, and as people got involved and did it more, there was a lot of pain in working with JavaScript and across the browsers. So as the browsers got faster and people wrote more code, we wanted to organize our code better. And in the language, there's no way to use the language to require dependencies, to import dependencies like we have in Python. In Python, we've had package importing from the beginning. You could organize your code into different modules, and in JavaScript, you just didn't have that. You had to add script tags to HTML, which is outside of the language. If you wanted to share things between modules, you had to put things into the global namespace, and there was plenty of conflicts. You had to kind of guess that in one script that your global, you had to refer to a global object you hoped was there, as that went along, people came up with ways to script the browser to insert script tags automatically to load their dependent JavaScript modules, and people figured out that instead of everybody doing it, they came up with libraries that helped require those modules in like JavaScript. It was require.js. You might have heard that. So you could just specify in the language using that API. And but it was still outside of the language. Sorry. No, I'm just, I'm not a great speaker, but, so, thanks. Sorry, please. So, one of the points about the industry progressing and it taking over a decade to get to the point where people were progressing more and writing more JavaScript applications, the pain that people felt was, other developers worked hard to try to solve it in different ways, and their work has made our current work a lot easier to do. You hear the phrase, "We stand on the shoulders of giants," but the people who did this work, I also wanted to recognize the people who felt the pain and expressed their frustration with how the ecosystem, the JavaScript and front-end ecosystem was. It was, and so they wanted to make it better, and so they tried, and eventually somebody figured out, like, somebody got the thing that everybody adopted, and we all applaud that one person, like John Ressig, who came up with a great API with jQuery. But there was plenty of us in the field working and trying out our different experiments, and that, to me, is a big part of contributing to open source. Is you don't have to be the successful one, that you can just feel good about trying out your solution, because that your failed attempt makes it more possible to us to get the winning attempt, Okay, so before I continue, I want to say a little bit about my organization, Workiva. We're more than just an engineering organization. I want to take a minute to recognize our human asset management philosophy and our ambassadors. We do have full-time HR professionals that really know what they're doing, but in the on the teams, we have ambassadors who they're people who are part of regular teams in different offices, and they act as a conduit for people who have questions and concerns, HR-related things. If they have, they also need to go to the doctor, and they, need to look up some specialist, and they're under stress, and they can ask, instead of trying to navigate a corporate website, they can ask one of these people on their team that they're familiar with. And it also goes both ways. These people get a heartbeat of different offices, of the office they're in, and they can, more quickly see if something needs to change and adjust concerns. They can answer the question of whether something might or might not be office appropriate, which is helpful, at all levels of an organization. And they come on, John. No. So they get together, and among addressing concerns, they also get together among our different offices occasionally in what is called a ham jam, where they get together to share the cultures from different parts of the country, and while keeping the Workiva vibe, as one of them, Lindsay Hanna, told me. We also have affinity groups in our organization for veterans and parents, and LGBT, for people of color, and for women, because we have people from all walks of life in our organization, and it's important to give them support. They're sometimes they're a minority. We have lots of parents in our company. It seems like one of my coworkers is always having a baby or two. They also organize and encourage people to attend events, to build a camaraderie. And as you're working together with other people, you want to like them and know more about them. So I talked a little bit about the history of front-end development. I didn't really get into style sheets or HTML. There's been plenty of kind of fights over whether we're doing XHTML or HTML4 and standards-based HTML. But now we have HTML5, and that's pretty good. We've got CSS, and some people like a more programmatic way of doing style sheets, such as SAS, SAS or SCS. And we also have style. There's also a new thing called styled components, which embeds styles right into JavaScript components. So onto the meat of the special sauce is the architecture of joining JavaScript backends to Python backends to modern JavaScript front ends. In a development environment, you want to have hot reloading or a fast feedback environment. So if you worked in Django or Flask and you're running a development server or even Pyramid, basically all of the different Python web frameworks have where you save your file and it reloads the changes. And so if you hit refresh, you'll get the new version of your code or load a new endpoint. We want to have the same thing in front end, where before it was very painful to load your changes to JavaScript because you had to fight the browser settings that were trying to cache the changes. So you'd hit refresh and you'd think it'd be loading your new version of your code, and it would really keep the old code. So you'd try to fix a bug, and it was just it was painful to iterate. You tried to fix a bug, and you tried something, and you hit refresh, and you thought your fix didn't work, but really it would have if you had really gotten it. So now that there's the ability with Webpack development server, and this is running in Node.js, to see the changes to your JavaScript and push it to the browser, how it reloads it. So you get both that ability on the front end and the back end. Now, in the back end, instead of writing your Flask with Python, instead of with Python writing your templates, producing HTML with the template language, such as Django templates or Flask, is typically you're typically using Agenda 2. You can change over to just serving the logic and the business data on the back end using JSON. So you respond, you get a form and you can respond with JSON. And that's easier for the browser, for JavaScript to interpret. And then because in browsers there's something called the same origin policy, which makes it so if you're doing a fetch or an AJAX request, as it's been called, to a backend, to an endpoint, if it's not on the same origin, you've got to jump through a bunch of hoops to get it to work. And so this has always been painful to do. There's a book called Cross-Origin Resource Sharing, and it's a book just to do this. So to avoid dealing with that pain, you can use a reverse proxy to connect them both to the same origin. And I'll show you how to do that later. So as I mentioned earlier, in Python we've got importing modules, and in the new ECMAScript 6, which is it's basically the more advanced standard version of JavaScript, but it's not supported natively by browsers. And browsers support ECMAScript 5. So the solution to keep us, instead of us waiting until all the browsers support a new language, like this is what we did in the last 20 years, is they would propose a new feature and people wouldn't really start using it, wouldn't develop with it. We'd have to wait till all the browsers came out with the new implementation. And so we were always seeing that that thing in the future. This would be a nice feature to have, but we wouldn't be able to use it. You know, we'd do experiments, we would be able to use it, but it was very painful to just kind of wait for the browser. So now we have something called Babel.js, which will take the new version of the language and transpile it into what the browsers currently support, into ES5. And there's also polyfills, which takes the standard way to do something, and if the browser doesn't support it, it implements it in JavaScript. So people get to start writing the standard way. They get to do experiments, and with Babel, it's plugin based. So if someone is proposing a new version of a new feature in the language, you can quickly try it out and use it. And this is make the JavaScript ecosystem move a lot faster. And I don't know if you noticed, but JavaScript, like the front-end development ecosystem, has been evolving pretty quickly. You're like, well, weren't they just using this library, and then they just, like, it seems like everybody overnight moves to the next technology. The community has gotten very good at managing that change, because everybody, you know, feels the pain of change, so they come up with tools and techniques to manage that change faster. And you'll see, it's not slowing down. There's like 150,000 packages in JavaScript packages. It's just moving quickly. So as a Python web developer, if you're not on in that ecosystem, it's a little bit FOMO. You're like, there's a fear of missing out, and you are missing out, because I felt this pain of, oh, I want to try that new package, but I don't understand how, how to import those modules in ECMAScript 5, regular old JavaScript. But once you have the Babel toolchain set up with webpack, you can just do it, and it takes care of dealing with transferring it to the old version of JavaScript. Package management. Modern front-end development means you get package management with JavaScript. We've got Python. You can install pip install things. It pulls it down from PyPI. Yarn is like a new version of a package manager. Basically, there is NPM, and Facebook came out with a little bit better version, which makes installing much more deterministic and faster. So you can Yarn add a module to your project. It pulls down the code, puts it in a node modules folder, and then you can just start using it. You can go import moment from moment, and get that functionality. It's pretty nice. Now the ECMAScript 6, these are links to the features of ECMAScript 6, and also best practices are coming out of Airbnb. People are really, that's kind of a consensus that they have the best practices. For editing, I like to use Visual Studio Code. It's actually written in JavaScript, because it's a yeah, the editor itself is a native application for Linux and Windows and Mac, but it's written in JavaScript. It's progressing quickly. It's got a lot of great features. It's got plugins, so you can open up a JavaScript file and it'll suggest the right plugins for you to use, and for Babel to basically get syntax highlighting for your ECMAScript 6. You can install Babel ES6, and I also suggest the Nginx configuration, because as I'll go into that, is there's a little bit of a configuration file to connect these things together. So you've probably heard of React. To get all this set up quickly, how are we doing on time? So to get all this set up quickly, there's a big manual for Webpack and Babel that you don't have to read. You can use the Create React App project. In Django, we've had, if you've seen the Django project, you can create a new Django project with a command line tool. It's like something like, basically create a new app, and it puts in files that are just like, okay, here's all the starter files. This works. You do that one command, and then you can start the development server and see a basic web page that has everything set up. This is very much like that, except it's for the front end part of it. And I put together a repo in GitHub that shows the recipe for creating the React app, creating the Nginx configuration, and also a basic Flask app. So this thing, you can check this repo out, and you can follow a few instructions and have it running immediately. But you can also follow the recipe of how I put it together, and follow the look at the commit history to see because I've made a few choices from the basic starter, just kind of doing some examples. So you don't have to start from, you don't have to include everything I did. And if you want to change something, if you want to use Pyramid or Django or Flask, whatever your favorite Python backend is that you know, you can do that. You know, it's not like this is just one way to do everything. So this is a web page that it started out as just the basic starter kit, and I added a few features. So So the name of this project is Carrot, and it's to draw Python users to ECMAScript 6 into modern front-end web development. It has a few prerequisites. If you're running on a Macintosh, they're all easy to install with Brew, the homebrew project. The basics are you create a React web app. And this is linked to the actual React app project. You set up a virtual environment for your Python, and it's a simple set of commands. Instead of using virtual env by itself or virtual env wrapper, the new Python virtual env controller is PyEnv, and this makes it easy to create a isolated Python environment to not pollute your other projects. You create a Flask app. This has got a very basic instruction on their site to create a Python file and to run it. And then you install Nginx, which is the reverse proxy. The reverse proxy basically does this. You can set up a server to listen on one port, and then when requests come into a specific path, they get forwarded to a different location. So with the default for Flask is to run its server on port 5000, and the default for Node is to run it on port 3000. So when the browser's loaded, when you're loading it from the browser, the reverse proxy lets you load. In this case, I have it set to 8080. That comes in and gets routed to the the Node application, the React application, and then when requests from the front end go to the /u, that gets routed to your Python paths. And React doesn't require Node, but it's in development, for the development server running Webpack. Webpack uses Webpack's written in JavaScript, and so it's basically running in the Node JavaScript engine. And so what this does is it watches your modulars, your files, and compiles them into ECMAScript 6. And when a request comes into it, it serves up those files from a virtual file system to the browser. But in production, you build your JavaScript files so they can be served statically. On this terminal, I have, This is the command yarn start to start the React service, or the JavaScript, the development server. So you'll see that when you do the yarn start, it tells the browser to load the port 3000, but to actually work together with Python, you have to change it to port 8080. Just open a new web browser, and this routes all the requests to the JavaScript. Now, I have a few buttons that make calls to the Python backend. So this just fetches some data from Python. And my Python endpoint returns the string hello PyBay. And then React shows it on the, React displays that change that it got. This is also an endpoint that returns a random string. Every time I press it, it's doing a new fetch to the Python backend. And you'll see in Flask, the slash is serving up the hello PyBay. That just returns a string, and the /rn returns a randomly generated string. You can also make a response that returns JSON. So if you've got data from a database, you can return that to the front end. Now, you're probably a little more familiar with this. We've seen we've seen our backend. I mean, we've seen this Python serving HTML. Sorry, serving strings and serving JSON. It's not doing. We're not doing render template. We're not returning HTML anymore. To produce the HTML, it starts off with an index.html page, which just has basically an empty body. It has a root, and the React app, it gives you this app.js, which is the component that when it first loads, it gets the root element and then renders the app module into that root. So that gives you basically the whole web page. From there, you can edit in you can edit in JavaScript what looks like HTML, but it's really called JSX. This gives you a more familiar interface to creating HTML. If you're a designer or have used HTML before, it makes it a lot easier than creating JavaScript objects and trying to manipulate the creating JavaScript React objects. It's pretty familiar with many web developers. Can you embed CSS? Yes. Well, this has an example of importing CSS. So, as I mentioned, as I was discussing before, we can import not only JavaScript modules but also CSS modules, and this has an example of importing the PNG, the image, and making it the name caret. Yeah, so where does it go? Well, when you do an import like this, it takes basically it does the job of importing it. Like just doing that import, the JavaScript. If you examine the ECMAScript 6, it would show you loading that. Basically, you don't have to worry about that anymore, because it'll control the browser. If the browser needs to have the JavaScript insert a style, import it, it'll do it. But it just works. So this is CSS that becomes available to this JavaScript when it's rendered. You see these class names. So there's a few changes. It's class name, yeah. In JavaScript, if you're used to seeing like it does everything in this snake case where the first character of properties are lowercase, and the it's like class name instead of class underscore name, or in this case it's just it's class name instead of class. The editor will it show you the difference? Like it'll suggest to you as you're typing it. Oops. The code completion. To insert, to make it dynamic, to make basically, okay, so we've got San Francisco, welcome to React. We've got the string hello PyBay here. That was returned from here, from Python, and I'll show you where that's set in the JavaScript, but it's set to the value of body, and so it looks like a templating language in your JavaScript that looks like HTML. So these curly braces make it, they kind of act like curly braces in Nginx 2. You can write JavaScript inside of them. Okay, so let me show a component has a, the app component, it has a constructor, or you can add a constructor where when it's first created, you give it default values for its state. I set body to an empty string, a random number to an empty string, and logged in defaults. And then there's the function called fetch hello, which does a fetch on the /u, and that goes to the hello slash endpoint in Python. If you've used jQuery before, you've probably seen the AJAX call, which its API to do an XML HTTP request, or XHR. The newer way to fetch resources is to use the fetch function. Newer browsers support it natively, and then browsers that don't support it this makes it work with a polyfill. It's a fairly clean interface. It returns. It acts as an asynchronous promise. So once the fetch returns, instead of doing it the other way, it has a then function. You give it a then function, so it gets the response and turns the response and either takes the text of the response, or in the case of JSON, if you know you're getting JSON back, it'll return the JSON of the body of the response. And that gets passed into the next function, the then function, in this case as the body. Then what this does is it sets the new state of the app. This is a ECMAScript 6 syntax for basically, instead of mutating the state, it creates a whole new state object. This creates a cleaner way to update objects, because I don't want to get into the details of immutability, but this is a kind of a way that works with this is a best practice. Let's put it that way. This syntax here is described on the ES6 features page that I showed earlier. What this does is it's got a ... and this acts like the double star in Python, where it spreads out the contents of the previous state, and then overwrites this kind of overwrites in that same call the body key. This lets you put in event handlers right into the button. So when I click this click that button, it executes that fetch. When the fetch returns, it updates the state of the object, and the object then React re-renders the content because it's changed. You don't have to get the result back from the server and then find the DOM element and update the HTML, the contents of the DOM element anymore. React just takes the render. It just basically looks at the render function, the new rendering with the data, and if it needs to change anything on the DOM, it selectively goes and updates that. It's a pretty efficient way to manage the DOM of your web page. It's not technically the fastest, but it's fast enough, and it's a lot easier than doing that manipulation by hand. What this in a single page web app, you want to have different views, and instead of having different full pages that execute different JavaScript, you can use something called React Router. This lets you link to different URLs, and as the URL changes, you can have your route component change out the view. This doesn't do a new call. This doesn't do any new calls to the backend. So topics get loaded. Topics just changes this this one component, and you can see I'm not changing the other part of the application. This also gives you history, because one of the things, if you've ever done a change to your DOM with HTML, you lose your history, and you also you've probably used a web app where you've changed to a specific view, and then you bookmarked it, and then you go back to the bookmark, and it doesn't actually bring you to that part of the site or part of the application. To do that by hand, I've done this, is I wanted to implement that history and tracking of the URL, and it's extensive amount of work. You can just drop in React, the React router, and get all this functionality for free. So I can hit the back arrow. It goes to the old URL, the previous URL, and it changes the route. And this allows for kind of that fast changing of your page, but also keeping that history that people and functionality that people expect from a web application. So how are we doing here? I think I'm ready for questions. So this is a quick way to get started. You can check out the GitHub repo. This has the instructions where you cd into. You have a terminal for your the Flask part of it. So I CD'd into the into the actually I'm just in the route of it, but I run this command which starts the Flask, does the Flask run with hello.py as the application. That starts that running, and then in another terminal you do yarn start, and that gives you that starts up the development server, the front end. Nginx acts as the reverse proxy, and this gets you easily past the same origin security policy for browsers. So if you ran your front end on port 3000 and you wanted to make calls to your Flask app on port 5000, you'd have to set up headers that make it okay for the browser to do those fetch requests to your other port. So this is just an added layer of complexity to putting the two things together. Does that make sense? Okay, well, so am I wrong? Does it have a problem with cross-origin sharing on the same host but different port? I think it does, but also a more advanced setup of this is to use different different hosts using Docker, where you can set up basically a distributed kind of like two different hosts by host names and combine them. So I don't know the answer to that exactly. I mean, I'm yeah, so to kind of repeat that is, you know, the discussion is about, okay, why include Nginx, and having it set up like this also lets you kind of scale up in the future. If you want to have two different instances of Flask running or different different backend, you can swap them out pretty easily. it kind of mirrors the features of like load balancers that you get in that are available in different like production environments. Yeah, I don't know Heroku specifically, but yeah, like all the like different cloud environments. This lets you get started developing with kind of a minimal overhead. This has the so I wanted to show this the fetch request itself. This is making the call to port 8080. So I have this login button, and this is something I set up. I added to the repo last night called login, and it shows using basically you make a request to the login URL, and this doesn't do any authentication. It just sets the username to John and logged into true, and creates a cookie that if you used the Flask session thing, you could set a cookie, the session cookie, and it responds to the front end with set cookie. So this is how you could start creating a login and track people when they come back to individualize settings. And then instead of this saying PyBay, when I do a fetch again, it sends that cookie, username equals John, back to the hello route. And if the username was set in the cookie, it responds with hello username instead. And this is how you can communicate that state across different requests. If you used the Flask session and a database lookup for the more detailed user information. And this shows an example of using the fetch to send those cookies. So the credentials setting of same origin will return cookie values to your Flask endpoints that from the same host, same origin. Sorry. Any more questions or any questions? How do I deal with testing? Good question. So yeah, so separating your JavaScript into different modules and components make testing a lot easier. They make it possible with continuous integration systems. And locally, you've got Yarn test, where the Create React app gives you some test files for your application, and you can just run them. It watches those files, and this shows here the app test, and this is kind of like a unit test that we do in Python. This does a basic test where it's testing it it's not testing in the browser, but it's testing it in Node.js. So it loads the component and basically virtually renders it without using web browser. Yeah, so the initial test is it renders without crashing. We can change it so it does render with crashing. I mean, it does crash. So I made a mistake. So, I missed a closing brace, and immediately showed me where in my code the problem started. So this is another nice feature of modern development. You're not using the. I don't even want to describe the horror it is to find problems in JavaScript through the browser and hitting reload is just like painful and slow. This fast feedback gives you a much nicer experience. So this shows me where my problem is, the line my test failed. I go and fix it, and they pass. This is just doing PWD. So I'm in the yeah. Yeah, this is just a terminal application. I mean, it's yarn test, and the create React app has the test script that I can show you in just a sec. But it basically runs a script that loads up testing tools. I think this one is using what's called Jest, but it's a test runner that just watches your files, compiles them, and runs the tests. Oh, so this node modules, when you do yarn install the first time, and that's just the command that initializes the node modules. It pulls down all the dependencies from the registries. In it is one called React scripts. Hold on. Yeah, so here's the script that gets called. So you can explore these scripts. You have start. This is the start command. What it executes, it's launching the webpack dev server. This is the test command, so you can explore this if you want to, but it basically works just out of the box. Any other questions? And again, this is the URL of the repo where you can check this out, get it running, and once it's running, you can iterate quickly. You can try searching for new packages, install them, and tweak the code. It's a fast way to get experience, and then you can build the next great front-end web app from there. So that's pretty much it. Thank you so much. It's really an honor to be here. Yeah, there's going to be a recording of the talk and a recording of the screen, and she's recording me, and we'll get that shared eventually, and we'll also have the slides available. Yeah, let me just show so you can get the contact information.